Persistent organic pollutants are chemical species characterized by their high thermal and chemical stability and their persistence in the environment. Likewise, they can give rise to phenomena of bioaccumulation and biomagnification, and reach the highest levels of the trophic chain, even reaching human beings. Its main drawback lies in the fact that these compounds have been shown to have high toxicity, producing adverse effects on exposed organisms and on the environment. Production and use of these substances and their control in the environment is regulated by the Stockholm Convention. The control activities are specifically detailed in the Global Monitoring Plan. It provides a harmonized framework for the collection of representative and comparable data, which allows observing trends in the different sampling locations worldwide. For most persistent organic pollutants, the reference matrices are air, in the case of the environment, and breast milk or serum, in the case of human beings. For other substances, such as fluorinated compounds, the environmental reference matrix is water. In this video, the main stages to perform the collection of an atmospheric sample by using an active sampling are described. To this end, it will be necessary to use an active high-volume sampling device, which allows collecting an amount of air sample enough to reach the limits of detection that the most modern instrumental techniques can provide. The basic principle of a high-volume sampling device consists in the collection of ambient air with the help of a pump during a period of time that can vary from 1 to several days. The air is passed through a filter, which retains the particles, and a module, inside which different adsorbents are disposed, such as polyurethane foam and a polymeric resin, XAD2, capable of retaining our target substances. The device has control systems to set the flow and the sampling period, thus allowing us to know the sampled volume. Frequently, these active sampling devices provide additional information on basic parameters such as atmospheric pressure, temperature, or humidity. As mentioned, the sample is collected in a filter and some adsorbents. These elements will be located in separate modules that will later be attached to the sampler. A wide variety of filters can be used, although the most common are glass fiber filters, GFF, or quartz filters. The shape of the filter depends on the geometry of the module to be used, and this is specific for each device, and therefore depends on the manufacturer. The filters can be used without a preconditioning process, although thermal conditioning can be carried out before being used. Regarding the adsorbents, a combination of two different ones is going to be used: polyurethane foams and the polymeric resin XAD2. This will allow us a more efficient collection of all the compounds of interest. The adsorbents cannot be used as they are supplied by the manufacturer, and prior to use, a process of conditioning is required. In the case of POOF, conditioning depends on the type of substances to be collected. Briefly, this process is carried out in an ultrasonic bath with ultra-pure water, followed by a sequential extraction in Soxhlet with different organic solvents. First acetone and later dichloromethane if sampling and analysis of basic POPs or the 6-indicator PCBs is going to be carried out, toluene if sampling and analysis of dioxins and dioxin-like compounds or brominated compounds is going to be carried out, methanol if sampling and analysis of fluorinated compounds is going to be carried out. In the case of the polymeric resin, conditioning consists in sequential Soxhlet extractions during extraction periods of 24 hours each, using organic solvents. First methanol, then acetonitrile, and finally toluene. Once conditioning is accomplished, sampling modules assembling can be performed. In general, a number of equivalent active air samplers are commercially available and supplied by different manufacturers. In our particular case, the filter is placed in a filter module. We will take the module and put it on a flat and firm surface. Then we proceed to open the compartment where the filter has to be placed. Next, we take the filter and place it properly. Finally, we close the module. Adsorbents will be placed in an adsorbent module. This module consists of two threaded parts made of polymer. In addition, inside there may be some extra parts, such as a glass cylinder, for a better placement of the adsorbents. Nevertheless, the whole module and elements may vary depending on the device and the manufacturer. The adsorbents may vary depending on the compounds to be collected: polyurethane foams, PUF, polymeric resins, such as amberlites, or activated carbon. In this procedure, the combination of PUF and the polymeric resin XAD2 is used. Preparation of the adsorbent module starts by taking the glass cylinder and placing the smaller PUF at the bottom. Then 10 grams of the polymeric resin are added, and finally we place the biggest PUF at the top of the glass cylinder. Final step consists of the placement of the glass cylinder, containing the adsorbent, inside the adsorbent module. We will make sure that the biggest PUF is always placed on the top part. Finally, we will screw the cap, put an identification label, and the device will be ready to be used. Once the modules containing the adsorbents and filter are ready, we are able to start the sampling. In a sampling campaign, selection of the sampling site and the placement of the sampling device become essential aspects to be carefully considered. It is also important to take into account that an electrical power supply point near the sampling site will be needed. Also, special attention must be paid to the presence of architectural barriers, such as walls, which could prevent a proper sampling process. Before starting the sampling collection, some aspects should be considered for a proper sample identification: location, sample identification code, date and time of sampling start, expected date and time of sampling completion, and target compounds. For sample codification, a coding process that consists of a set of letters and numbers is used. This system unequivocally defines, for each sample, the country where sampling is undertaken, target compounds to be determined in each sample, and sampling date. Thus, the code will be composed by a set of 3 letters that will refer to the country in accordance with the ISO codes used by the United Nations, followed by a hyphen and a number related to the target compounds, and finally, in parentheses, the date of the sampling. This shows an example of an identification code: country UN ISO code, type of sampler and code for target compounds, and sampling date. Before starting the sampling, we will first install the adsorbent module, followed by the filter module. Usually, the connections of the modules are made of plastic. The connections should be fitted tightly, but without forcing them, in order to avoid their breakage. Once the installation is accomplished, the sampling can continue. 2 important parameters must be set before starting: flow or suction flow, and sampling period. Once these 2 parameters are defined, sampling can start. When sampling is finished, we will make sure that the sampling device is not pumping. If this is not the case, the pump must be manually interrupted. Next step is to disassemble the filter, as well as the adsorbent modules, and to take note of the collection data, including sampled volume, as well as any incident that may have been occurred. Finally, the sample must be sent to the laboratory to proceed with the analysis.